Hi everyone, we're going to talk about test-driven development using Python FastAPI. I'm Rukshan Senanayaka and let's talk about these topics today. Introduction to test-driven development. So we'll have some introduction to what test-driven development is and why it is there and how we can integrate it into our development workflows. And also we'll talk a bit about FastAPI testing framework and how we can structure these tests and what are the best practices that we can follow and how we can mock the dependencies for these tests, and also let's talk a bit about integration testing as well. So what is test driven development? Now, as software engineers or developers, whenever we develop an application that has crucial business logic to implement, we need to pay attention to the specific functions or specific things that we need our application to do. And in these cases, as developers, since we are also human, it is very possible that we introduce bugs or errors into our application. But the problem is, if one of our functional requirements fail due to these bugs or some issues in our code, then it's a very big business problem. To mitigate this, what we have in our teams is quality assurance team members. But the thing is, our testing should not start only at the QA level. Developers themselves test the code that they write. So this test-driven development is a great approach to do the testing as developers ourselves. So whenever we want to implement a code, what we do is we write the test case first and then we implement the logic to pass those test cases. So this test-driven development approach has three main stages. The first one is the red stage, or we write the failing tests. We deliberately write the failing tests. And then secondly, we write the logic that needs to pass the test cases. And then thirdly, we refactor the code, we optimize the code as needed, and all the non-functional things. But the important thing is, we start with the tests. Usually during development, if we are not following this test-driven development, we are just starting with our business logic, which is fine for simple applications, but if we have very business critical applications, then we might need to follow this test-driven approach to make sure our code is robust and free from bugs. So the benefit is we have a better design with our code. So whenever we do some changes to our code, we can ensure if these test cases are passing, then our code is robust. Like that way we can have some assurance by writing these test cases and following this test-driven development. And when it comes to FastAPI, which is a Python framework for developing Python applications, the testing is very straightforward because there are some tooling that are already available inbuilt in FastAPI and some packages like PyTest we can easily install to make our developer lives so easy. And also, not only that, we can test complex scenarios within our application logic using this PyTest and the inbuilt testing tooling in FastAPI. And when we go into the code, which we will in a moment, we can talk about the structure of the code and how we can do the actual coding to implement this test-driven development. We can discuss these things later. And also when it comes to mocking, for example, when we have database connections in our code, which is very common, we need to mock the database connections and the responses from the database in order to test our functions in a unit level. If we are about to test our code level, the functional level code, then we need to avoid the errors that may have occurred due to database connection issues or network issues from our code testing, because that is what a unit test is. We are only testing the unit, which is our function. So in that case, we mock all the external dependencies that are related with the function, and then we can ensure if the test is passing, then our function is also good. And integration testing. So in our functions, in our code, there may be a lot of components involved to our functions. So in that case, what we can do the integration testing. So testing these full request response cycles and database interactions, authentication, authorization, All of these things are very easy when we are using this test-driven development approach and PyTest in FastAPI. So without further ado, now let's get into the coding bit. So let's start fresh and let me create a new FastAPI project. So we can select FastAPI and you can select the location for the new project. And also I'm using Poetry as our project management tool and also the dependency management tool for this Python project. So here I'm selecting Poetry and then I create the project, and then we will have a working FastAPI project just starting from scratch. So we are using UVCon to serve our FastAPI application. So right here we have created our FastAPI application and we can just run it in debug mode like this. So we have our FastAPI application like this, which is great. But now we want to get into this test-driven development. How can we do that? I have another written tutorial as well, parallel with this video, so you can read through it as well. But in order to start from fresh, we need to add two dependencies to our project, which is PyTest and HTTPX. So PyTest is something that we use for test discovery. So whenever we write unit tests, it can easily recognize the testing files and makes our developer lives a lot easy. So we add the two packages to our Python application like this, and we're using the HTTPX package to do the requests. And okay, now we have added PyTest and HTTPX for our project. Okay, and now what we have to do is following the test-driven approach, a test-driven development approach. I mentioned earlier there are three main things. The first one is writing the failing test. The second one is implementing the minimum code to pass the test, and then refactor the code if necessary. Now you can think of these three steps like this. Whenever we have a test incoming, we have an examination incoming, we know in order to pass that examination, we need to score a certain amount of marks. So that amount of marks is set. It is already test. So that is like the failing test. But then what we do as students or as candidates for the exam, we study. We go through the material, we go through supplementary material, and then we improve our knowledge and experience and skills required to pass the test by obtaining the set amount of marks. Now in this, we can focus only on the business logic and then improve the code if necessary later on. Okay, so let's first write our first test case. So I have the code already. So the first thing is we actually have to create a folder, test folder, where all of our unit tests will live. So here we're going to create a new directory called tests, and it is important we need to create an init file as well. It can be empty, but we need to create it. And then what we can do is we can create another test for testing the function. So in this case we are going to create a simple to-do application and to-do testing. We're going to name it test to-dos. So it is very important that we name this with the test underscore prefix. That is how the PyTest can recognize our tests. So here test to-dos, and then I've copy pasted the code from my article, but I'll explain it. Okay, here what we do is we initialize a test client which is coming from FastAPI, and then we do an API request to an endpoint called to-dos with a JSON payload like this. So our to-dos will have a title, description, completed status like this, and then we assert the response that is coming from the request. So here, what do you mean by assertion? Assertion is checking against some sort of a condition that we have in order to pass the test. Usually in a test, we don't have multiple assertions. We can have multiple assertions, but just to be following the single responsibility principle, we only have a single assertion command usually in a test case. In that case, just for the completeness of this logic, I have added several assertions, but we can only, I mean, it is best that we have only one assertion per test case. So let's run this. In order to run this command, what we need to do is poetry run pytest. So when we run this command, poetry run pytest, what will happen is, I put all these commands in the description, don't worry. So when we run this command, what happens is all the tests that are inside this test folder will be run. So let's run this. But you may wonder, we only created the test case. We haven't implemented the logic that is required to create the to-dos. Exactly. And that is exactly the process that we are following in test-driven development. We write the test case first, and then only we write the business logic to pass the test. Okay, let's run this. It should fail. Okay, you can see it is failed actually. It is failing with this assertion failure. So we have an assertion failure when it tries to match the response code that is obtained here. So the response code that is obtained, the actual one is 404, which is not found because there is no API endpoint called to-dos in our application still. We haven't created it yet. But the expectation is 201, which is the usual response, the usual HTTP response code that we expect from a create endpoint. So you can see the mismatch here. We expect 201, but we get 404. Now our task as the developer or the engineer is to make sure that we get the 201 status response. And in that case, this assertion will pass. But in order to consider the test case pass, all of these assertions must pass. Okay, so it is not sufficient that we are only sending the status code. We have to have the payload, because these assertions also should have been met in order to consider this test case passed. So in order to have that working, what we need to do is we need to implement the actual logic. So let's go to it. So the first thing is we need to create this endpoint within our main.py, which is the main entry point for our FastAPI application. So for the moment, we are creating all of our to-dos in memory without using a separate database, just to keep it simple. But this is the same approach even if you are using a database as well. And just for the clarity, I'm using a model class for storing our properties related with the to-dos. So which is using the Pydantic models. So I can just rename it models.py for the moment. Models.py. Okay, so this is like the structure. Okay, I made a mistake. It should be models.py. Okay, and this is outlining the structure of our to-dos, and then we can simply import it in our main file. Now what we have done is we have implemented the actual business logic to create a to-do. So we can see, yeah, just having some simple ID with an increment as the to-do ID, and then we append whatever is coming from the request body as the payload that we create the to-do with. So in this case, in our test case, we have a payload with the title test to do and the description test description like that way. So let's try to run the pytest command again. So we run poetry run pytest. So what this command does is, again, it runs all the tests that are inside the tests folder, which in this case is creating a to-do and testing it. Okay, now we can see it is passed, which is interesting because now we have actually implemented the logic to create a to-do. So this line creates the to-do using a request, post request, and then it prints out the content of the response, but it's not properly formatted, so we are not going to see the actual output from it, but we can see the output using a debug point. So what we can do is we can stop the server, and then we can just debug the test, and then what this will do is it will create the to do, and then it will assign the response coming from that request to this response variable. And if we expand it, we should be able to see the actual response coming from that endpoint. So here it has created an it has created a to do, and this is the response content that we have. So you can see this is exactly the payload that we sent, and we can step over just to see how the other assertions also pass. Now if any of these assertions fail, we are not going to see this test case passing. Okay, so just for that, let's change this value, the title, to let's say test to do new. Now an interesting thing happens here. We expect our title to be test to do, that is what we want to assert, but in our payload we send the test to do new. So there is a mismatch. Now what happens is, since there's a mismatch, our assertion at the line 10 should fail. Let's see if the assertion at the line 10 actually fails. Okay, let's run this now with the debug point set to the 9th line, and okay, we are running it. We are now on the line 9th line, and we have no errors with the 9th line because it is indeed a 201. But this time we can see the assertion at the 10th line has failed. It's interesting because it's very clearly showing which assertion has failed. So here you can see the expected is test to do, which is what we have here, and then the actual that is coming from the response of the request is test to do new. So you can see this is a clear mismatch of what is expected and what is actual, and this mismatch causes the assertion to fail. And whenever one of the assertions of this test case fails, the whole test case is considered failed. So this is the beauty of test-driven development. We can outline our business requirements as test cases, and then we can write or focus on the business logic or the code or the implementation separately to pass until we are passing the test case. So here, if this is what we need to do, I mean, let's consider this payload is to do test to do new. So let's assume the logic that has to be implemented in our function is to actually get rid of this word to do new. Then our test case will pass because the new word will not be found in the response. So similarly, even for very complex business logics, we can scale this simple concept of test-driven development to make sure our code is robust. So even if in the future that we may need to modify our code, for example, if we need to modify this method, then we can assure that until as long as our test case is passing, our main core logic we can consider is successful. We can consider it's working perfectly. Okay, so we have the assurance of as long as these test cases are passing, we can ensure that our logic is working correctly. Okay, so that is mainly about the create endpoint, but in a CRUD application, for example in this to-do application, we do need to have other endpoints as well. So how do we go about them? It's the same exact procedure. We first, for example, let's take the read operation, which means we are getting the to-dos. So here we just need to create another to-do with the test case. We just need to first create the test case and then implement the actual logic. So you can see, and similarly for the update operation, similarly for the delete operation as well. Here in these consequent operations, I have added some code to create the to do on the fly, just to make sure that we have to do to read, to do to delete, to do to update, like that way. This is like a prerequisite. But yeah, it's same procedure for the other consequent operations as well. And one important thing is I mentioned something about fixtures. So let's say you have some external dependency that you need to integrate into your function. So maybe a database connection. So in that case, PyTest allows you to mock them very easily. So if you need a database connection, you can do something like this. So fixtures, we can then inject these fixtures into our testing code. So I'm not going to go into the very deep details into that, but just make sure that Python PyTest actually gives you some sort of functionality like that. Okay, and I had the code prepared earlier, so I can show you the all the things that I mentioned here. So I'm going to git checkout into the main branch. Okay, git checkout main, git pull. Okay, now let's run the poetry run PyTest. Mind you that I have created the other test cases as well. So here you can see the create one that we created earlier, and then one for the to do, and then one for the update, one for the delete, like that way. And also I have updated these complementary methods, the actual logic that are required to create, read, update, and delete the to-dos as well. And then when we run the pytest command, you can see 4 tests are passed, which means our create, read, update, and delete, all the test cases have been passed. So which is great. I mean, now as long as these test cases are passing, we can ensure our business requirements are met. So that is the whole point of test-driven development. We ease our mind, and also we make sure our code is robust as long as these tests are passing. So even if you have not heard of testing, even you have not heard of unit testing and test-driven development earlier, I think now you got some sort of an introduction of to test-driven development, and I think you can try out with FastAPI, which is very easy to test this test-driven development development with. And I think you got something out of this video, and if it is so, it's a pleasure of me. And also don't forget to go through my written tutorial, which I'll link in the description below as well. Okay, so that's it from this video, and thanks a lot for watching. Let's meet in the next video. Till then, take care.